Okay, consider the curve given by this formula. So when I read that, I remember that this is the formula for finding the points on a curve. Show that the derivative is equal to that. So taking the derivative of both sides, you're going to get 2y, y prime, must equal 0 plus, now you need the product rule. Because this is plus, you don't have to have a parenthesis, but it doesn't hurt anything. So second times derivative of the first plus first times derivative of the second. dy dx and y prime are the same thing. So now I have 2y dy dx y dx dx is 1. This is going to move to the other side. So I have 2y dy dx, subtract x dy dx equals y, and I factor. And divide. 2 points for that. They'll give you 1 point if you get to here. And then the second point if you get to here. So 2 points total. How many steps do you have to show? You could skip this one and go right to this step. That would get you the first point. If you go from this step to the end, they'll give you the second point. So you don't have to show these 2 steps in between. Find all points on the curve where the line tangent has a slope of 1/2. So we have this formula back here. dy dx equals y over 2y minus x. y dx equals y divided by 2y minus x. We're looking for where the slope is 1/2. So we want this to equal 1/2. So that has to be a place where the y coordinate so we have to try and see if we can solve this equation. So I'm going to multiply both sides by 2y minus x and multiply both sides by 2. That will give me this formula. Or 2y is equal to 2y subtract x, like that. Conveniently, when I move this to the other side, I get 2y subtract 2y is equal to negative x. So 0 is equal to negative x. Multiply both sides by a negative 1. X is equal to 0. So it appears that when x equals 0, slope should be 1/2. We have to make sure that x equals 0 is a point on the curve. So take the equation plug in x equals 0. Oops. Which would give us y squared equals 2. When we take the square root of both sides, we get two possible answers. Either the square root of 2, or we get y could equal negative root 2. So what we figured out is when x equals 0, the slope is 1/2. We could try that over here, because if you plug in x equals 0, you get a y divided by 2y, which is indeed 1/2. And then when we plug in that x coordinate into the formula for finding the points, we find out that the point's going to be 0, root 2, and the other point is going to be 0, negative root 2. So we have found both points where the slope is equal to 0. Sorry, slope is equal to 1/2. This is a good example of just do as much as you can and keep moving, don't get stuck. They gave you 1 point for this. So that came pretty fast. Then all the rest of it, getting to here, was the other point. So even if you couldn't figure that out, it would have still been worth your time to, of course, get that far. As soon as you start feeling stuck, you should stop and move on to the next problem. So 2 points total on that part B. Show that there are no points on the curve where the line tangent is horizontal. So that means we're looking for where dy dx, slope, which is our formula y divided by 2y subtract x. We want horizontal tangent means the slope is 0. When you have a fraction and the result is 0, the only way that can be true is if the numerator is 0. So we just figured out that the y-coordinate would have to be 0 in order for there to be a horizontal tangent. We're supposed to show that there are no points. So y equals 0 appears to be the only way you can get a horizontal tangent. So now we go back up here and say, okay, what happens if y equals 0 as far as the points on the curve? So we have, change color. We have y squared equals 2 plus xy. So plug in a 0 for y. And we get nonsense. This side of the equation is going to be 2, because this is 0. 2 cannot equal 0. Therefore, there are no points. Because again, the y-coordinate would have had to have been 0. But if the y-coordinate is 0, like this, we can't, there's no x that makes this true. There's no way to get an x that will make that true. 0 doesn't equal 2. So there are no points on the curve where tangent is horizontal. my marker to work. Huh, funny. Okay, the way they gave points on this one is 1 point for figuring out that y would have to equal 0 in order for there to be a horizontal tangent. 1 point for the rest of this work. Be your best judge as to whether you would show enough work below this line to get that second point. But 2 points total. So part C, two points total. Now we already showed that part B has 2 points total. And then also part A was also 2 points. Okay, let x and y be functions of time t. So x and y are functions of t. And they're related by this equation. At time t equal 5, the value of y is 3, and dy dt is equal to 6. Find the value of dx dt. This is a related rate problem that's kind of hidden because they're using x and y, but they're saying x and y change with time. So we have our amount and rate thing here. If you're looking at DREAD, you've got our amount. So in this case, the amounts are just the values x and y. We have rates. We have one rate, dy dt. That's given as being 6 when time is equal to 5. The value of y is equal to 3 when time is equal to 5. Supposed to find dx dt at that exact same moment. That's very common for related rate problems, to find what's happening at a given moment in time. This is our moment. So we've got our Danica's chart done. Did that. We've read the problem carefully, got all the rates written down. We need an equation that combines the rates, the amounts, EA, amounts. They gave us the equation. So now we need to take the derivative of that equation with respect to time. So we have y squared is equal to 2 plus xy. Here's a bit of a tricky part again. Taking this derivative with respect to time. So we're doing this. Again, it's not new. You've done this before, just have used different symbols. So that's why the AP test writers are so good at making the test look different. So this now becomes 2 times y dy dt, not dy dx. This becomes, the derivative of our constant is still 0. You still have to use the product rule. So you take the second times the derivative of the first. Remember, this is still dt here, plus first times the derivative of the second. Trying to find dx dt, this one. We know this. We know this. Okay, we know, we don't know the value of x. But we have an equation that shows us how x and y are related. So we're going to use that. Just come up here in the corner here. So when x is 3, sorry, y is 3, you don't know x, y is 3, you get 9 equals 2 plus 3x. We rearrange a little bit. You get 7 is equal to 3x. Means x is equal to 7/3. So we can use that right here. So I'm going to get 2 times y is 3. Y is 3. Dy dt is 6 equals 0 plus the y is 6. Trying to solve for dx dt. The x value is 7/3. And the dy dt is 6. Just solving for dx dt. We don't have to do anything with this. We can just leave it alone. It's bothering me. 6 times 6 is 36. These will divide to make 2. 2 times 7 is 14, so that gets subtracted over. And all of it gets divided by the 6. And that's my dx dt. And I made an error here. Gotta go slow and careful. The value of y is 3. I had plugged in a 6. So this is 3, meaning this is also 3. And you can stop there. Okay, this part was worth 3 points. Here's how they awarded the points. So this is part B, was 3 points total. And the way they awarded the points, 1 point for finding the x value, 1 point for correctly taking the derivative, which is right here, and 1 point for the final answer. Okay, consider the differential equation. So that's an equation for finding the slope of some curve. Let y, or f of x, be the particular solution. So this equation, y, is going to be how we find the points on a curve. And one of the points on the curve is -1, 2. Write an equation for line tangent to graph of f. So we've got some curve. We don't know exactly what it looks like. It's called f. We know there's a point on the curve where x is -1, and the y value is 2. We know that we have this equation which can be used to find the slope anywhere on this curve. So the slope right here, slope at that point, we're looking for that slope because that's the same as the slope of this line right here. Those two slopes are the same. So we take dy dx at x equal negative 1, y equal 2. That's going to equal, use parentheses in place of the variables is a good practice. The 2 gets squared first. That makes 4. Divide by 2. These two will divide. So you're going to get negative 2 is the slope. But honestly, to be safe, helps. Negative times negative is positive 2. That's a really good example of where I would have been better to just leave the slope like that. I don't lose any points and just write down the answer. I got cocky and made a mistake. So y equals slope, negative, parenthesis, x minus the x coordinate, which is negative 1, plus the y coordinate, which is positive 2. And they gave 1 point for doing that. So this is part E. And it's 1 point total. Okay, find the solution to the given differential equation. So they're giving us a rate formula right here. They're asking us to find an amount formula, so we've got to use the SASSY method. So on dy dx, multiply the dx across, that's always the first step. And then it does help to separate the variables on this side a little bit, kind of like u substitution. I've got y squared multiplied by negative x over 2 multiplied by dx. So now I'm going to have I prefer to write negative 1/2 x. Like that. That's going to get me 1 point for correctly separating. Okay, now to do the antiderivative, I want to rewrite this y to the negative 2. Can't use the ln rule here because this is y squared. So this becomes y to the negative 2 plus 1 divided by the same. This becomes negative 1/2, that's a multiplying constant, x squared divided by 2 plus the c. So if I get that far, I get 1 more point for doing the antiderivatives. One point there. Let's see, this is y to the negative 1 divided by negative 1. But y to the negative 1 over negative 1, same thing as dividing by negative 1, same as multiplying by negative 1. Y to the negative 1 is 1 over y to the first. So this is just negative 1 over y. So I have negative 1 divided by y. It's going to equal. I can leave this as is, or I could multiply this out right here. That would be negative x squared over 4 plus the constant. So we plug in the initial condition. Replace the y with a set of parentheses and a 2. that's the y value, equals negative 1/4. Replace the x with the x value of negative 1. So this is negative 1/2 equals negative 1 squared would be positive 1 times the negative 1/4 would still be negative 1/4 plus the c. When we add 1/4 to both sides, we get negative 1/2 plus a fourth equals c. So c is equal to negative 1/4. In this case, they gave 1 point for finding c. So that's 3 points total so far. Last step is to try and isolate the y. So here's our equation. We know the value for c. We want to isolate the y. This isolation step's not too bad. So let's copy this over. And let's erase a little bit. So we have our equation. Negative 1 over y is equal to negative 1/4 x squared, and then the c value is negative 1/4 as well. The best way to solve this equation is to think of it like this. Negative 1 over y is just equal to a whole bunch of stuff. So therefore, multiplying both sides by y, dividing both sides by a, we get this. So now you can just write down the answer. Negative 1 divided by all this stuff, which was what I called a. That was the last point. Therefore, part F. So F was 4 points total. 4 points. Okay, part G says, find this integral. Don't have any formulas that look like this, so I'm going to think u substitution. This looks like a good choice for u. Take the derivative of both sides. So du dx is equal to negative 18x, which works great because except for the multiplying constant of negative 18, it matches this perfectly. So what I have is I have an integral of x over 1 multiplied by 1 over all of this to the 1/2. Moving this to the numerator, I'd have this integral. So I have two functions multiplying. I choose u from the second of the two multiplying functions, this part of the second. The derivative of my choice does end up being a multiplying constant multiplied by the first of the two multiplying functions. That's what we want for u substitution to work, so we can keep going. There's no limits to change this time. Don't forget, sometimes you do have to change the limits. Oops, let's rewrite this the other way. So we have u to the negative 1/2. Then we have x dx. So over here, we get du is equal to negative 18 x dx. Move the 18. I think a problem like this, they would normally give you 2 points. For this practice test, we're assigning 1 point to the problem to make the practice test a bit more challenging than the real test. So we're going to have this is equal to u to the negative 1/2 multiplied by negative 1/18 du. So copy this over. We don't need this anymore. And we have, this is going to equal negative 1/18 antiderivative of u to the negative 1/2 du. So now we have a rule from the golden notes. This becomes u to the negative 1/2 plus 1 divided by the same plus a constant. You don't have to go any farther because algebraic simplification, numeric simplification is not required. And again, because we made this practice test a bit more challenging, 1 point if you can get all the way to the end. If you kept going, this would be negative 1/8. You shouldn't keep going, you should stop. But this would be the square root of u, because this is u to the, oh, messed up. It's not, you can't stay with u, you gotta go back to x. The bottom here is going to be positive 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So now I have negative 1/18 multiplied by 2. That I can leave, but the u replacement has to go back. So I've got to plug in the 1 minus 9x squared. And 1 point to get that far, just 1 point on part G. So G is 1 point total.